Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good day to everyone. Okay, so today we're going to learn about braking method for DC and AC motor. Okay, actually there are three methods that we're going to cover for our syllabus. Okay, so for both DC and AC method, the name given is similar. Okay, so let's look at for DC motor first. Okay, the braking method for DC motor. Okay, so the first method is dynamic braking. Okay, so in this video I going to explain about how all the three methods work. Okay, in term of IA, armature current, and in term of circuit connection. Okay, for dynamic braking, okay, so actually when the supply to the field winding is maintained. Okay, so the first condition when the supply to the field winding or field circuit is maintained. Okay, and then the second condition, okay, the armature circuit is disconnected, okay, from the supply and will connected to the R external. Okay, so in this case, okay, we can call, so R external is RDB. DB stand for dynamic braking. Okay, so that is in term of how dynamic braking works. Okay, so next one, okay, the second method is plugging braking or counter current braking. Okay, plugging, or we can call as a counter current braking. So how does this method work? Okay, armature current. Okay, armature current. Okay, we know that armature current is IA. It is reversed by reversing the source terminal. IA is reversed by reversing the source terminal. Okay, so we interchange between positive and negative terminal of terminal supply. Okay, so in next video I will going to show the IA and then the circuit connection for each braking method. Okay, so the next method is regenerative braking. Okay, so this, how does it works? Okay, when back EMF, electromagnetic force is exceeds the applied voltage. So so in another word is, okay, when we write in term of equation, okay, EMF, okay, is greater than, okay, VT, okay, terminal supply voltage. Okay, EMF is electromagnetic force, okay, and then VT is the applied voltage, okay, our terminal or supply voltage. Okay, so for dynamic braking, so the equation for IA, the equation IE for dynamic braking is given by negative EB. So B is stand for braking. So armature voltage during braking. So EB divide by RA plus RDB. Okay, so as I mentioned earlier, RDB is our external resistor. Okay, for this method, okay, we going to name as a DB. Okay, stand for dynamic braking. Okay, so IA equals to negative EB divided by RA plus RDB. Okay, so this negative sign, okay, shows that the armature current is reversed. You remember earlier how it's work, okay, by reversing reversing armature current. Okay, how dynamic braking works, okay, by reversing armature current. So this is negative sign. It shows that the armature current is reversed. Okay, negative sign shows, okay, the armature current is reversed. Right. Okay, so the next important things, okay, for braking is circuit connection. Okay, so for during normal condition, okay, for this example, we going to use, okay, shunt connection. Okay, let's say we have, okay, RA in series with EA. Okay, this is armature circuit, and then we have, okay, a field circuit that parallel with armature circuit, and then we have our VT, okay, our terminal supply, positive and negative. Okay, so during normal condition, so this is IL, okay, IA and IF, okay, positive and negative. So this is RA, this is RF. Okay, so, okay, the direction of IA is comes from terminal, okay, positive terminal to armature circuit, okay, positive and negative EA. Right, but then during the dynamic braking, okay, during dynamic braking, okay, let's say we have RDB, okay, then this is RA in series with RA, and then we have RF, VT, positive and negative. Okay, so during dynamic braking, okay, we mentioned earlier that the armature circuit is disconnected from the supply, so this one will be disconnected. Okay, but for RF, for field circuit, it will maintain, okay, connected to our supply. So this will be disconnected from the main supply, and then it will connected to RDB. So this is our RDB. Okay, so this is EA, RA. So for this case, okay, so we know that, okay, the current will be flow from positive to negative. So the direction for IA is reverse. So instead of, okay, coming down, and then it will be coming up from positive EA, and then it will flow through RDB and going back to negative EA. So that's why, okay, the direction of IA during dynamic braking is negative. Okay, negative sign show that armature is reversed. Right, so next we're going to continue with plugging, or CCB stand for counter current braking. Okay, plugging, the other name is CCB, okay, counter current braking. Okay, first let's start with IA. So what is the equation for IA for plugging method? Okay, so IA is equals to VT plus EA over RA. Okay, so IA equals to VT plus EA over RA. Sometimes we, okay, write EA as a EB, so indicates that during braking. Okay, EB stand for brake, braking during braking. Okay, so this is equation for IE, Vt plus EA over RA. Okay, so in terms of circuit connection, okay, for normal operation, okay, the similar circuit, okay, as shown in previous circuit, which is we use, okay, shunt DC motor. So we have Vt, RF, okay, RA and EA. So this is during normal operation. Okay, so remember that for plugging method, okay, the armature current reverse by reversing the source terminal. So this is positive and negative source terminal. Okay, for during plugging, okay, the polarity for, okay, supply terminal is reverse. Okay, for armature circuit lah. Okay, it will reverse at armature circuit. Okay, so during plugging, so let's say we have this one. Okay, positive, negative Vt. This is RF, RA and EE. Okay, so this is positive. The positive will be connected to negative of armature circuit. So this is armature, consists of RA and EE, armature circuit, positive and negative. Okay, during plugging, okay, positive terminal, okay, will be connected to negative side of armature circuit, and then this one will be disconnected. Okay, this one will be disconnected from the supply. Okay, so positive will be will going straight to negative. Okay, this one pun akan disconnected, and then for negative side, okay, it will be negative side of supply will be connected to positive side of armature circuit. So this, okay, okay, this method is known as a plugging method. The supply is reverse. Okay, the supply is reverse, or the armature current is reversed by reversing the supply terminal. Okay, so if we draw the direction armature current, okay, from positive, it will flow, okay, this way and this way. Okay, this is IE, armature current. Okay, and then it will going. So if I can draw, okay, the direction of armature current, okay, so it will flow from positive, and then it will okay, enter negative EA, and then continue flow, okay, until going back to negative supply. Okay, so for this equation, okay, how we get IA Vt plus EA over RA. Let's say we okay, write KVL equation, start with negative Vt, okay, plus negative Vt, then akan minus EA plus IA RA equals to 0. Okay, negative Vt, and then we start with negative Vt, and then okay, dia akan jumpa dengan negative EA, and then plus IA RA equals to 0. So if we rearrange, okay, this equation, IA equals to Vt plus EA over RA. Okay, so this is the equation for IA during plugging, okay, or counter current braking.